Okay. Short and sweet. Literally 5 slides. All right, lesson number 4, valence electrons and ions. And this will finish us up for topic 3. All right. Valence electrons. These are the ones found in the outermost electron shell. Elements that are in the same group have the same number of valence electrons, and that's why elements that are in the same group also have the same chemical reactivities or similar chemical properties. It's all based on those valence electrons. So the ones in the outermost shell, the highest energy level is going to contain our valence electrons. This will also be the last number that is listed in an electron configuration. So if you're giving 281, 1 is the valence electron. For example, phosphorus is 285. That is its electron configuration if we were to write that out. So 5 is the number of valence electrons in phosphorus.
It's still based on the numbers.
I mean, yeah, it's the same thing ish. But I mean, the 285, if you look at phosphorus, phosphorus has an atomic number of 15. 2 plus 8 plus 5 is 15. And then if our first energy level can contain 2, our second energy level can contain 8. Our third energy level can contain a maximum of 18 electrons, but we only have 8 in it. So 285. And if you read the periodic table, if you were to start from left to right, if you read across the first period, that's 2 elements. If you read across the second period, that's 8. So there's 2, 8. And then if you read across in the third period until you get to phosphorus, 1, 2, 3, 4, 5. Yeah. Most atoms are completely stable when they have a completed valence shell with 8 electrons or an octet. So atoms will gain or lose electrons to increase their stability. A neutral atom will have an equal number of protons and electrons. Their charges are balanced. That's why it's neutral. Ions, on the other hand, are going to have an unequal number of protons and electrons. Of course, the proton is going to stay the same. That's not what's going to change because that identifies our element. But we can add and subtract electrons. And when we do that, if we add negative charges, we become more negative. If we decrease negative charges, we become more positive. But an ion is a charged atom. It's no longer neutral, like electrically. There are two types of ions. Hopefully you remember these. A positive ion is a cation. We used to say cat ions are positive. Yep. Positive cations have fewer electrons than they do protons, and they are formed by metals when they lose electrons. So 80% of the periodic table is metals. They are going to lose electrons in order to form cations. Anions are the negative ones. They have more electrons than protons, and they will be formed when a nonmetal gains electrons. The nonmetals are found in the upper right-hand corner. They like to gain electrons in order to achieve stability, making them negative. Yes. It is situational. The ones at the top generally will form an anion, but not always. And then the ones at the bottom, like tin and lead, since they're metals, they will form cations. Germanium can kind of go either way based on what it's in, and then carbon can actually act as an anion in some places, but generally carbon and silicon only do covalent bonding because they make four, they just share. That's organic. It's all about carbon and its 4 bonds. My good grace. You need this. There's really nothing to write down on our final slide here. This is just a good way to look at and kind of have a visual representation. So if we were going to compare a cation to its neutral atom, if you look on the left side there, we have an electrically neutral sodium. The configuration would be 2, 8, 1. Okay, so there'd be 2 in its first orbital, 8 in the second orbit, and then 1 in the last. And we can actually compare that to a Bohr model. You can see there's 2 in the first orbital, there's 8 in the second, and then there's 1 on the outside. If we were then, though, to create the ion here, this last electron listed is a valence electron. That's the one that's going to get lost. So we lose this electron, bringing our configuration to just 2, 8. And you can also see that demonstrated in the Bohr model. We've lost this outer electron. When we do that, then I have 11 protons in the nucleus, but only 10 electrons in the cloud, giving me a positive 1 charge. Questions? Okay. That's it.